And we continue with a presentation with the same level of interest, for sure. This is coming from COCUS. Please welcome Frank Meisel. He is Director of 5G Customer Projects at COCUS.
Good morning. So I believe the green one is for the next slide and red for the next. I want to talk about why measurements are important, and I have some topics which I want to go in detail from our existing projects. First of all, let's talk about the short agenda. COCUS is not a very known brand in this area, so I will start introduce COCUS, and then I have 3 topics from our existing customer projects. One is about video upload and what we did with measurements tools, and we work very close with Rohde Schwarz here to use QualiPOC scanners and so on. The next one is why we believe that it's very important that also the radio planning tools are calibrated, and what are our lessons learned in the campus networks, what we built so far. And then the third topic, which I will cover, is how we deal with indoor deployments, especially for tenders when a customer asking, we have a hospital where we want to have a 5G indoor coverage, and there we don't get so many insight about the walls, the concrete, what materials, how thick are the walls, and what is our approach to do so. COCUS is about, we have more than 170 employees in Germany. We have 3 locations in Germany. So one of our biggest is in Düsseldorf. It's very close to the Vodafone campus, which is one of our biggest customer. And we have another big apartment. This is in Portugal, where we have around 150 employees. Mainly the development part is done in Porto, but also there are Scrum Master, project manager as well, and we work together with the German and the Portugal team. Some of the DAX and the Fortune 500 companies are on our customer base, and COCUS is existing more than 20 years. So the next one, what I need to have a look here. COCUS is a service and solution provider. We have an in-house development and departure. We do development in agile way work. We have customized solutions for companies and organizations in all sizes and brands. We are also at your side end-to-end, so it's starting from the design, development, technology, integration, also cloud infrastructure, big data analytics, of course, user-centric visualization, and last but not least, also application and process automation. That is overall what COCUS is doing. So we develop solutions that make a difference. I want to focus now on the 5G Campus to Go, which is our solution, what we offer to the customer in the 5G area. So our 5G Campus to Go solution is, first of all, it's based on Open RAN. It is an open system. We have the user can have accessibility to all cases, can go to every container, can do traces. It's not a black box. Everything is open. It is scalable. We have everything is a cloud-based approach. It can be virtualized. It's based on standard hardware. On the picture here, you see that's one of the racks what we built for in our office, bring to the customer, and here you see that we tested that on some commercial out-of-the-shelf servers. It's Dell servers, HP servers, Intel servers. We are here flexible what we use. Overall, COCUS, as I said, is more than 20 years on the market. So what we also offered for every customer, we start from the radio planning to the integration to the network, and also what we try to do is our approach is as easy as Wi-Fi. So we want to integrate it into the existing customer network. So that is, it can rely on the Active Directory of the customer. It can use their IPAM tools. That also smaller companies has the possibility to run a 5G campus network in their own premises. Let's go to the next one. So we break that also down so that we see that we have also the capabilities that smaller companies can have easy. We call this as a starter kit. The starter kit is one of our smallest setup. It's based on one server. It can be choose either indoor or outdoor. There are 2 radio units included. It's 5G standalone solution. We will deliver the SIM cards, everything at once. The system is fully pre-configured, and it can be up and running in a couple of days on the customer environments. And that is available from €75,000 onwards. This system is still our starter kit, but it can grow. It can be expanded with many more radios. It can be bring from a single server solution to a high available system. That's why we call it as a starter kit for the customer. But I want to focus also on the stuff which we have in our customer environment. This picture is done from one of our customers. It is ZF, and it's a test track in Jeversen. On this test track, the company ZF is doing autonomous driving, do all test of the trucks. Many other different cars are here on this track. Here you see the bank curve on that one. And we covered indoor and outdoor of this area. It's about 2 kilometers by 1 kilometer, the outdoor coverage for that one. And also several indoor halls are covered from our solution. The focus here was uploading data from the cars itself, but also sending video. It was one of the first events after the Corona stuff that this is a pre-event for the EAA, the automotive event, and hundreds of those customers from the big brands are invited to at that time to go to the test track and see the video from the truck. So you would see the trucks driving around the test track, and in the same time the cars was equipped with many cameras. You see, for example, one was on the steering wheel, the other one was on the trailer, to see that no one is really steering the car, and you also see the trucks directly driving around that one. I want to talk about some challenges what we had here at that time. First of all, the radio planning tool was at this moment uncalibrated tool. It was a tool which was used also for macro network planning, but this was not calibrated to our 5G radio units. One of the reasons for that one was that at this time we received the radio units very late. We got the first samples coming out of the factory, and this was one challenge. The next one is that because it was a fixed day when this event happened, we also worked close together with the customer that he was able to build up all the poles, all the cablings for preparing the outdoor stuff. And on some location we need to make some compromise. For example, there was an existing fiber ring, but they used some switches, which was one of the reasons why we decided not to use the split architecture on the outer ring. We used an all-in-one approach with RU, CO in one box, because we can reuse the existing switch infrastructure around the racetrack, or not racetrack, test track. And also, for example, the fiber connection was in the inner side of the ring, which I will show in the next slides what was the issue on that one. Also, as I said, the use case was zero latency video upload. So when you close to the location and see the truck driving around you and see on the video screen, and you see a huge difference. You see the truck already move, and the video is many seconds behind. That was not feasible to do so. And this brings us to one part which was also not optimized, that the video codecs was chosen was not optimized for mobile networks. And I will show also why this was also important. So when we started the radio planning tool, let's go back. It's better to see it here. So for example, at the point number 11, there you see an inner point where they want to place the poles. But this one will show us that you cannot send the radio signal over the curve, because there are woods and this was a little challenge on that one. With the radio planning tool, the planning was really good. It shows us very strong signals, more than minus 70 dB RSM up to 60. So there were no blind spot what we observed. And overall, we said, well, we can go with that one, with that setup. The red part is woods and trees inside the track, which is not used. So you really see the streets, which are important for the customer. On the right-hand side, you see one of the poles. The poles are at a limited height because the time sensitive of this project, it was not allowed to use very high poles because to allow that one, it is close to an airport. And you see, we built at the same time a 5G network and a Wi-Fi 6E network from Aruba at the same time. And some poles, we used the same one. But in Wi-Fi, they used more poles for the Wi-Fi network than we need to use for the 5G network. Here is also visible on below. You see that's the full GNOT B RUDUCU in one box, and we use passive antenna mounted on top, back-to-back montage. But you see in the radio planning tool that it was originally planned that we can send the data really at the end of the curve, which is nowadays, when the pole that finally was built, was not possible. So this one was a tricky part. Also, the test track was more overgrown than when the event was. Initial first visit was in winter. The vegetary was not that huge like in summer. So what we did afterwards is, you see again some pictures, the back-to-back montage. Also on the building, we have the same one. You see the Wi-Fi network, you see the full GNOT B in the middle, and the passive antenna on top of the building. That is what we do. We were faster to build up the 5G network than the Wi-Fi network. So that was interesting. That was really working hand in hand with that customer. The first thing what we did is, because the final test setup was not yet available, we said, well, the video upload or data from the truck was not that very data intensive. They said about a 4K video, it's around 15 megabits per second. And you see on the left-hand side that we drive all around the test track. The dark blue color is when we achieved 69% in a coverage of more than 15 megabits, and then 3.7 in between 10 to 15. So overall, we have 99.8 something percent capacity what we need for uploading the video. On the right-hand side, you see just the signal strength of the system. And if you compare that one to the original planning, this shows us dark green, sorry. It's about minus 70 to minus 60. But reality was way different. So we're talking about there minus 95. So it's a huge difference. And also you see the yellow point on the end on the curve, that this one is already in the end of the coverage because the trees are too big. Overall, so this looked like that 99.9%, everything is good for the video upload. But in reality then, it's also a big difference on what type of car we did the measurements. You see here on this bank curve, you see the truck, which is driving around, and we did the measurements with a regular car because the truck time was not available to do the testing, and also not with the final video use case. So what we did here, you see on the left-hand side, it's a huge difference if you do it with a car, while you do it with the truck, which is 4 meters high, has external antennas. That makes a big difference, especially here in this bank curve. In reality, it's looking way more impressive. This bank curve is very high. It's about 40 degrees. It's amazing to drive there. But that was also something which we didn't expect at that moment. So you see the red point with the car, which is a way better signal with the truck. So we did some iPerf testing because the video setup was not available, as I showed on the pictures before, all good. But What we found out is that it's a huge difference if you do just sending video data, real video data with low latency approach, or if you do just sending iPerf with a very small amount of time where you look where you have interference. So one of the big, let me go back. So now you should see that also a video is starting. One of the best thing what helped us was that we optimized also the video codec for that one. On the left lower side you will see an original example video. On the right hand side you see an optimized codec that is called SRT. That is a secure reliable transport protocol, which can deal with packet loss and also with higher latency, and it also has better compression. So what the video solution from the customer use an RTMP stream, which is very regular, YouTube, Facebook, Twitch, they're all platforms using that type of protocol, but this is not optimized for wireless networks. It's still not an cable network. You will see that there is, from some time there will be jitter, there will be packet loss, and here it's just 2% packet loss, and you really see those glitches. That you see the video is stopping. And exactly that happened when the first truck was driving around the test track. When we have a handover between one to the other antenna, we do have a very small interrupt, about 20 milliseconds. But if the video was done with a codec which is not aware of jitter and packet loss, this brings you to that. Let me go back. Show it again. Let me start it again. And this was really then an issue to optimize the network. So what we did is to optimize in the best way what is feasible. And at the end, we helped also the customer changing the video setup with some SRT, and also this is just an example. I was not allowed to show the details from the truck. So normally they use 4 streams. One was filming the steering wheel. The other one was filming forward and backward to the truck. And originally they sent 4 video streams. And if you have 4 separate video streams and you have packet loss, it can happen that this RTMP stream will get out of sync. You see the steering wheel was already moving while the other video stream was some milliseconds behind that one. And so this one was for us the key thing to change at the end. And finally, we did a measurement. Then we drive around the test track. We send the video from the car. So you see that's me in the car, because we did the type acceptance here with just my car. And so we were pretty happy about what we achieved on that one. And no glitches at all. There was plenty headroom to send video from more than one truck. Okay, then the next example what we have, so one of our bigger project is also in Sea Harbor. That's the Sea Harbor in Wismar. It's a 66 hectare big area, which you cover indoor and outdoor as well. And there they realize many use cases. For example, there's an automatic ship loader. There are remote driving vehicles. We will have drones. Many use cases will be implemented in that area. What we did there is also, at this time, the radio planning was done with a different tool. It was also showing very, very strong signals. So the tool was used out of the box, feeding with the proper data of our radio equipment, with the power, with the antenna pattern. And then we had this setup, and it shows us really strong measurements up to -40 degrees. Not degrees, sorry, -40 RSRP in strength. And here you see the coverage. You see it's in the indoor buildings. We use many poles on that one. And the remote control vehicles also needs a very stable and sufficient network. Also the ship loader, which I come to in detail about, is very time sensitive, needs low jitter. It's a Profinet solution, and also the 5G drones, because that harbor is for wood and TORF. I don't know the name for TORF. It's for fire protection, to use thermal drones to see if you have any fire things happen in that one. But here the message is why we believe that when the radio planning tools need to be calibrated. And this one we also did together with the colleagues from Rohde Schwarz. We had some nice time here in Wismar to use all the scanner equipment and measurements. So let's come to that one. So what we did after that one, we said, well, this is what comes out of the radio planning tool. In the Sea Harbor, there are this lifter already available. We mounted the antenna and did some reference measurements, including the holes, because some holes they have salt inside the holes, which is very aggressive to your radio unit. You try to avoid not bringing the radio unit into that holes, because maybe you see it on the picture that everything is rusty and your radio unit will be really be out of service pretty soon. And the good thing here on this lifting platform, they have many of them already in the Sea Harbor available. You can change the X and Y and also the tilt, everything from the lifter, which gave us the possibility to do this reference measurement very easy. We use here, that's just an example what we use. We use the scanner, we use the Rohde software, we use QualiPoc on that one. So this one was the first measurement with just one radio unit up and running. And we use that input to bring it into the tool and do the calibration. And now you see that this purple color is not there anymore. And also the legend also changed. If you look in detail to that one, you see the original plan out of the box was around minus 50, and then with the calibrated, then we talk about minus 90. So the difference with an uncalibrated tool is really huge. And remember, it's a logarithmic scale, so the minus 50 to minus 90, that is a different world. And it's still enough, so we planned the network, everything up to better than minus 105 would be enough, depending on the area where we need more data or not. Let's jump to the next one. What we also agreed that when other parties are doing the radio planning, we will work on many public tenders. That means that we say, well, we need to agree that the radio planning needs to match the actuals. So we defined many points where we said, well, the radio planning needs to be, I don't know, maximum 10% difference at certain locations, and that is what you see here. We use here now just a different way, that it's not full color, that you do this continuous versus discrete in the coloring. And here you see what is the signal power what we want to achieve, and then we do the measurements with and that one we use the scanner and also the QualiPoc, and then we can say, well, approved, this radio planning is feasible, and we achieve everything what we try to do. But why are we doing that details of measuring and calibration? So this is this automatic ship loader. It's using 3D LiDAR scanner, real-time RTK for exact positioning stuff. This system is remote controlled. It's sending video data, but it's also very time sensitive. So it has a dependency for low latency, low jitter, all that stuff. And we just summarize that up. You see here an example of this ship loader with the cameras. The upload traffic is not that high. We're talking about approximately 100 megabits in upload. And on top of that one comes the Profinet part, another 10 megabit for controlling, and the amount of CCD cameras. And they defined that the maximum latency here is around 30 milliseconds. Because that one, the ship loader is not moving that fast, so normally it's also lower on that one. But if you don't meet the criteria, the ship loader will go to an emergency brake, and then someone needs to go out of the office, go to the ship loader, and start it by a manual, that one. So what is really important for them that we have also the very low latency and jitter that the system is more predictable. Sarah talked about a lot of TSN. At the moment, our network is not TSN supported, so it's something on our roadmap. But what we do is we optimize everything to the feasible stage, what we can do. We optimize the handover zones for that area where the ship loader is moving. And quality of service is one of the parts which we can say that this one is more important than the video of that one. And we use here, for example, what really was very useful for us was the tool for the latency measurements. And then we started in our test lab with the small environment from this Profi network and to optimize the network, and we'll bring that live in July. So everything what you will see here will go live in the next couple of months. Okay. How do I say, how I am on time? Okay. 1 minute, okay. Then I speed up. One of the last thing is, as I said, we do some measurements on site of the customer. So there's a public tender, as I said, at this hospital. A hospital gives us some floor plans, and then we need to do a calculation how many indoor radio units we need. What we do, we have here you see in the white box is the all-in-one solution. We use here an airspan, RU/DU/CU in one box. We go to the customer also in the pre-sales phase, spin up the 5G network within a couple of minutes. We go to the Bundesnetzagentur first and ask for a test license. Then we do the measurements on site, and then based on that one, we calculate everything. We did here. You see the measurements. We're moving around. This pictures from the QualiPOC. And based on those information, we have way better results from the customer with the real insight. So we can ask 20 of questions. So what are the windows? Is the shield? What kind of material is used? But we decided this is way better to go on site, do the measurements, and based off that one, we build a model if it's 10-meter radius, 20 or 40 meter for indoor coverage, and so we can. And so you see that the difference is very big. So when we achieve 10-meter radius in a dense area versus 40 meter in maybe an industry hall, is way different than an office building. And 300 square meters versus 5,000, that is a big difference. And all those public tenders are fixed price projects, so you need to do it very properly in that phase. All right, that was my main task.
Thank you very much, Frank. I couldn't interrupt you. That was so interesting.
Okay.
Thank you. My most important question: could you drive the truck through the bank curve?
I was not allowed because the truck was also self-driving, so it was not that. I was allowed to sit in and look that no one is taking steering, but still there was a people inside for security reasons. So if it was really also very impressive. They make emergency brakes, and also they open some brake flaps. And if you are doing your measurements on site with your small car and this heavy truck is coming to you with high speed and making the brakes before you, that's really impressive. But I was not allowed. Just sitting inside the truck.
That's so interesting. Kids, yeah.
Exactly.
Questions from the room. Oh, let's see. Christoph first. Simon here. Yeah, please wait just a second.
Hi Frank, this is Christoph from Nokia. Very interesting presentation. I was especially interested in the point where you mentioned that the radio planning needs to be calibrated. My question would be, do you have an idea why the difference is so high between the predicted signal strengths and what you then measure? Is that because of the link budget model was completely unrealistic, or do you have any idea where this comes from?
That was also a question we asked. I believe maybe that one solution could be that our radio has less power than it was in the data sheets. But we believe what you said, the link budget things was not fully done in the right way. Because we did not the radio planning. I cannot talk it in detail, but the only thing which I was knowing is that, well, minus 40, I don't believe. That not with a radio unit which has 2 watts of transmit power. So we do not have this very powerful radio units 2 watt and passive antenna which gives us another 20 dB. So overall it's a strong signal, but not minus 40 in a couple of 100 meters in that spectrum. I don't know why. I believe at this stage they were all coming from the big network with the high powerful radio units. Maybe that was the reason. And we observed this not with just one tool, also the other one. One was IB Wave and the other one was WinProp from Altair. Really interesting.
Thank you.
Next.
Hello, Frank. My name is Luis from Bron IPOS. Thank you for your presentation. I have a question in regards of the trunk case, the test. So you showed a couple of graphs, one for throughput and another one for coverage. But you also mentioned that delay and jitter was important for this use case. So I was wondering if you also performed some interactivity tests to perform to check that.
As I showed, the interactivity test we use also with the Rohde Schwarz to optimize the network to have the very minimum jitter and also to do everything what we can. For the drones, I believe it's not that very important. It's more for the remote control vehicle. So the drone is flying in a very 50 meters high. There was more the challenge that the passive antenna which we use has a very small angle in elevation, 7 degrees or 22 degrees. And it's a huge difference if you optimize your network for this AGVs in 1 meter or the drone in 50 meters. That is huge difference.
Thank you.
Some more. Yep, maybe here.
Maybe a quick one. Port of Wismar. I know it's not yet started, but
it is well prepared. So we need just that they finalize the last poles of the civil works.
Question is, in a port environment, you have a lot of changes. You have these piles of peat. You have ships with transmitters on it. And
exactly.
How do you deal with that?
So one of that one was. That we can use high poles. So there was some buildings with we have around 30 to 35 meters, and then you have the chance to cover the radio signal from this high pole. This helps a lot. Or you can use more radios coming from different direction. But I agree. So when you go to a break, comes 1 hour later, there is a huge pole of wood with 10 meters high, 20 meters width. The area is changing a lot. That is one of the challenges, of course. So the answer would be more than one radio cover one area, and if it's feasible, to use higher poles on that one. That helped us.
Peter?
Hi, thanks. Really, really interesting presentation. Thank you very much. One question regarding the ship loader and the emergency stop. We are testing our network in Teisnach at the moment on basically interactivity long term, so really over a week. And sporadic, we see really packages going really long time for no reason at all. I mean, it's a stationary test. We are not even moving the modem, but we see it's going all right. And then after a couple of hours, dong, a couple of packages are going wild. Is this the same in your network? Have you tested this?
So the most latency test we did also for a shorter period of time. But what we did is when we drive around this test track, it was for a couple of hours, but not weeks. So I hope we don't have this issue. So we optimize the best what we can. Also, we are in contact with this company who built the ship loader. They will bring the equipment to our office, and there we will do long time testing. And I believe the difference would be not so big because this ship is moving just a couple of 100 meters from left to the right, so it's not moving all around. So we can simulate that in our lab, that we have longer time experience on that one, which we will then test, of course, to see if the emergency stop will happen. Otherwise, it will be a challenge to go there and unlock the emergency stop and everything. Yeah, of course.
Thanks.
So maybe we should talk.
Due to timing, I think I have just a closing question. Did I get you right? Was it your recommendation to say anybody who is using a radio planning tool should use test equipment to tune it and to calibrate it?
I didn't mention the company, but I agree.
No.
Yes, yes, they should.
Okay. Thank you very much,
And we
Frank
do.
Meisel.
We do. Thank you.
Frank. Kleines Präsent.